And so we'd like to have Dr. Macrae up, and he is the president and CEO of Sangamo. Welcome.
Good morning. Good morning. It's a pleasure to be here. I'm Sandy. I'm the CEO of Sangamo, but in a previous life, I was a physician and an endocrinologist in the UK. And so I'm speaking partly for my responsibility for Sangamo, but also as a doctor who saw patients and understands the journey. It's been a really enjoyable meeting. I want to call out the work that Lauren presented about the speaking plainly in how you describe things. And it's, I think, a lesson to all of us, and I'm going to try and replicate her work when I describe the results of our science, because what we're going to talk about is gene therapy, which is a very different thing to talk about in a very new world, I assume, for many of you here. And so Debbie and I will be around over lunchtime if any of you want to come and ask questions, no matter how simple or complicated those are. We're here to try and help you understand what it is we're doing. We're going to talk about ST920, which is an investigational drug. So it hasn't been approved by the agency, and it's only in a clinical trial at the moment, which puts it in a different category from the works of our friends at Sanofi, Chiesi, and Amicus. And it's a very, very simple concept. You get an infusion that lasts 2, 4, 6 hours, depending on the amount that's being infused. We do it currently as an inpatient, but there's no real reason for that. Eventually, I think when this is approved, it will gradually move to being infused as an outpatient. The worst symptoms we've seen is occasionally people get flu-like symptoms that are addressed by Tylenol and some antihistamine. And then you go home, and over the next 4 to 6 weeks, the gene is gradually expressed. Now, when it's infused into your bloodstream, it goes to the liver. It goes into the liver cells, which is this kind of soccer ball type thing on the top right, and it stays there for the rest of the life of that liver cell, and it produces the enzyme. So in contrast to ERT, where you get big boluses of enzyme given to you every 2 weeks, this is a constant flow of enzyme coming out of your liver as naturally as possible. So what are the advantages of that? It's a one-time infusion. I'm struck that there is less of a conversation about the burden on each one of you that has to go for infusions every 2 weeks. I can't imagine designing my life around an infusion every 2 weeks. It gives you consistent, durable efficacy. So there's something coming out of the liver every day at a constant level. And you don't get the variability of the peaks and the troughs of a large enzyme infusion. The evidence that I'm going to show you suggests that it gets good efficacy. So what we see is an improvement in renal function, a stabilization of cardiac function. But what really means something to, I think, each one of you is how you feel through that. So for the doctors, we like the cardiac and renal function discussion, but it's things like how you feel, how you sweat and suddenly recover your sweating, your quality of life, your pain, your GI function. Those are the things that mean something to you day by day, and we believe that this medicine shows an advantage for those. So this picture is very simple. It's just the 32 patients that have joined the trial, and it shows how long they've been in the trial. And the longest patients at the very top have been in over 4 years. There's now 3 patients that have been dosed for 4 years. That's a very long time in a gene therapy trial. And we're now at the stage where we have the 32 patients that have been dosed for 1 year, and 19 patients have achieved 2 years. And the results at 1 year are what we are going to focus on in this conversation. But the result you see at 1 year predicts what you're going to see at 2 years. So it's a very constant, stable, long-lasting effect. The other thing that you can only see through the colors on this chart is we recruited a variety of Fabry patients. We initially started, because that's what you do in trials such as these, with males, and then we've moved from there to recruit females, to recruit patients with cardiac disease, to recruit patients with renal disease, to recruit patients with antibodies, and those without antibodies. And that's the kind of kaleidoscope of colors that you see on the chart here. The remarkable thing is there's no difference. All of the patients that we've recruited have shown a benefit. Now, these are patients 18 years and older, and I'm really struck by how the Fabry conversation is going to younger children, and that the symptoms occur, as we heard this morning earlier, and that the benefit should be attempted as early as possible. When you do a trial in a genomic medicine, you always start with the benefit risk and the safest population with adults, and you gradually move it into children. And the obvious next thing for us to do would be to do a trial in adolescents and then move into children. But for the moment, the evidence, the data is all from 18 and above. And this is the bit of statistics I'm going to show. So there's two box and whisker type plots. On the top one, it's at 1 year for the EGFR, and in the bottom one, it's at 2 years for the EGFR. Now, I've never had a patient come in and say, "Doctor, my EGFR isn't right." EGFR is when they get you to pee in a bottle and they measure your renal function by showing how well the kidney is functioning. But as a patient, you might feel tired, you might feel your energy is sapping, you just don't have the ability to go shopping, run after your children, and that might be how you start to find out that your kidney function is not as good as it should be. And what we saw earlier from the surveys from the 3 other companies is that over time, a Fabry patient's renal function declines faster than a patient that doesn't have Fabry. But what we found in our survey or our study, which is really unique, is that our patients' EGFR, their renal function, improved. This has not been seen with any of the other medicines. And the way you compare it is you do kind of meta-analysis. You gather all the data that's available in the public domain for the other treatments, which is the dot and the whiskers to the left, and you compare it to our treatment. Our treatment improves renal function for the 32 patients that we've studied, compared to existing therapy, which slows the decline but doesn't improve it. And I think that's important, because it's not just about your renal function. Renal function begets total body function. And it's not just the energy you have, but cardiac function is often linked to renal function. And so this is a very good marker for the benefit that our medicine will have to the patient. EGFR is also something that the FDA understands and is likely to be able to approve the drug based on an objective measurement such as this, because you can't influence peeing in the bottle and then measuring the EGFR. We've also started to look at cardiac function. We had anticipated doing a dedicated cardiac study, and so we did a variety of measures to try and test to see which one we would do a dedicated study. But the data is so compelling that we're planning to submit this for approval in the first quarter, second quarter of next year, and hopefully to have it approved by the second half of next year. And what we saw with the existing study is that the cardiac function is stabilized. Now, in Fabry patients, there can be a gradual decline in cardiac function over time. So this stabilization in itself is a very positive thing. Why does this happen? What's the benefit? I'm going to show you first in naive patients. So these are patients that haven't had any treatment at all. And if you look on the left-hand side of the graph, you'll see this kind of spaghetti of patients' alpha-gal plots, the enzyme that's produced in that soccer ball of the liver and gradually leaked out every day at the same amount. What's the right amount that this should be producing? The blue smear along the bottom, the faint light blue smear, is what people without Fabry produce and can measure in their blood. It's what I would have. Now, for me, my alpha-gal is produced in every cell in my body. It does its work in the cell, and then it leaks into the plasma. And that's what we're measuring there. So it's already done its work by the time I'm measuring it. For patients who have got gene therapy and a factory in the liver producing the alpha-gal is produced, goes into the bloodstream, goes to the cells, and then it does its work. So you're measuring it at a different point in its journey. And we try and compare it to what patients without Fabry have, but the comparison isn't really apples to apples. And I don't know what the right amount is. The way I know that we have got sufficient is the benefit it gives to the patients for their renal function, for their heart function, for their sweating, for their pain, etc. And so we can compare each one of these patients, and all I can tell you is each one of these patients feels good. And when you look on the right at the lyso-Gb3, which is the thing that accumulates in your cells when you have Fabry and is not good for the cells, you can see in these naive patients, they come in with high levels, and all of them drop, and all of them continue to be at a lower level than they would have been because of the production, day after day, minute after minute, from the liver. We also recruited 18 patients who had been on ERT. And if you look on the graph on the right, you can see towards the left-hand side of that graph a series of yellow stars. And that's the point where each one of those patients came off of ERT. And because we were the first gene therapy like this to study this, it was really, they came off at the decision of them and their doctor. So there wasn't a, you must be off by this certain date. But what we've discovered is of these 18 patients, 17 of them have stayed off. And the longest that anyone has stayed off is 3.5 years. 3.5 years is 100 weekends of infusions that patient no longer has had to go through. The one patient that went off was a very individual physician decision, and in a clinical trial, the physician always has primacy in deciding what happens with their patient. But the 17 other patients that have remained off ERT remain happy, and the benefit that we've seen, that I showed you for the renal function, is despite them coming off ERT. So if you look at all the measures of success, when they've come off ERT, not only have they done well without ERT, the benefit that we've seen in all patients has been seen in the patients that have come off ERT. So they've improved in the way they feel, they've improved in their renal function, their cardiac function has stabilized. Suggesting that what we're doing is a more physiologically appropriate way to treat Fabry disease by giving a little enzyme every day, every minute, going to the tissues and making sure that you get the benefit. This is numbers and statistics. I've been doing drug development for 27 years. This is the most beautiful medicine I have ever seen. And by that I mean the balance of the effectiveness and the safety is everything I could have hoped for, we could have hoped for. The middle section here is something called SF36, which is a quality of life measure that I've put in every trial for 27 years, and it's never been positive. It's a complicated test that varies how you feel every day. And the remarkable thing about this trial is the number of parts of the SF36 that are not just positive but are statistically significant. It's a very, very rare thing to see so much benefit. And if you look at the words that are the different parts of the SF36, they mean something. Vitality, body pain, social functioning, general health, physical, and the kind of things that if you speak to a patient, it means something. It's how you feel, it's how you go through your day. But it's also, you can see on the bottom, the GI function improves, and the physician scale, the FOSS-MSSI, that improves. And this is happening across those variety of Fabry patients, men, women, renal, cardiac. It really is a medicine that seems to be applicable to all forms of Fabry disease. Why might the people on ERT feel better on this? When you give ERT, you almost immunize the patient each time. It's almost like a vaccination. And what we found is if you treat them with gene therapy from the liver, you tolerize the patient, and you can see that the antibodies that often reduce the effectiveness of the ERT disappears when you give gene therapy. And I'm going to finish on 2 more slides. I can see the music is about to start. The most important is the safety. This is all of the adverse events that we've seen in these 32 patients. And there are a series of flu-like symptoms that people sometimes get at the start during the infusion. After that, there's very little, and it's remarkable how unremarkable it is. We don't give steroids as prophylaxis. We don't give steroids at any other point in the treatment. The medicine seems to be well tolerated. And I'm going to end with this about our thanks to all of you, and everyone does this. It's particularly important for genomic medicines because those in the clinical trial who chose to take the first dose of a genomic medicine are very brave and do it for the rest of you and the rest of us. They take a medicine that is going to be with them for the rest of their days, not knowing the effectiveness of it. Some of us, the rest of us, me perhaps, are slower adopters. And now we have 32 patients. We have 4 years of data. I think it's a different conversation now. And we hope and look forward to having this medicine approved next year and perhaps bringing benefit to more people. Thank you.
Thank you so much, Dr. Macrae. Sandy?